So this is day 2 of Unit 3. We're looking at Chapter 5, Sections 1 and 8. We're throwing a couple of ideas together. So let's talk about what this is. So yesterday, the last day that we did this, we talked about absolute value. And the absolute value equation that we used was y is equal to a times the absolute value of x minus h absolute value of x minus h plus k, where h and k was the vertex. We're going to see a lot of the same type of stuff here, but it's going to be just slightly different and a couple different techniques. As always, you can go to print out the PDF, or these notes can be taken on course pack page 503 and 504 of your course pack. So pause now, either print out the PDF or get those course pack pages. All right, so just like yesterday, my form of my equation deals with my vertex, and this is my vertex form. So when I'm dealing with the vertex form, it's going to look like, can't put it that high. It's going to look like this. Y equals a times x minus h squared plus k. It looks a lot like absolute value. That's why we started off doing absolute value. Just like absolute value, I'm going to start off with my vertex hk, where h is the opposite of what I have inside the parentheses, and k is exactly what I have outside the parentheses. Instead of an absolute value here, we have a parentheses and a quantity squared. I have my line of symmetry, which is x is equal to h. Let's see if I can get it to come up. There it goes. Put this back. And so that also draws in my axis of symmetry, x equals h. Notice I put this in as a dotted line. It's not actually part of my graph. It just shows that it's symmetrical. The left side and the right side match each other. It's a mirror image of each other. Okay, so let's go on and see. The parabola opens up if, just like on absolute value, if a is positive, and it opens down if a is negative. The parabola is wider than the graph of y equals x squared if, the same way, a is between 0 and 1, and it is more narrow if a is greater than 1. It is exactly the same as if a is 1. Domain and range. My domain is x equals the element of all real numbers. My range, just like on absolute value, y is less than or equal to k if a is negative, and y is greater than or equal to k if a is positive. Now, I've talked nothing about how to find other points on my parabola other than the vertex. I cannot use a as a slope because this is not a straight line. I'm going to talk about two different ways of doing this problem, and you can choose the best way when it comes to finding other points. First way. So y equals negative 2 times x minus 4 squared plus 3. What are the coordinates of the vertex? Again, I want to look inside my parentheses and put the opposite is 4. Outside the parentheses, the same is 3. So my first coordinate, my vertex is 4, 3, 1, 2, 3, 4, up 1, 2, 3. What is the effect of the value of h on the graph? It shifts up 4. What is the effect of the value of k on the graph? That was a lie. It shifts right 4. What is the effect of the value of k on the graph? It shifts up 3. What is the value of a? A is negative 2. Will the graph be wider or more narrower than y equals x squared? Since this is a is greater than 1, the absolute value of a is greater than 1, this is more narrow. it's going to stand up taller or shrink in taller. The graph is going to open down because it's negative. What is the axis of symmetry? Axis of symmetry is x is equal to the x coordinate of 4. So here's my x coordinate of 4. So how do I go ahead and find other points on my graph? Well, before we do the domain and range, there's a quick way and a longer way. The choice is yours. The longer way, I'm going to do an XY table. I'm going to start with my coordinate 4, 3, right in the middle. I want to pick numbers that are smaller than 3, 3 and 2, excuse me, smaller than 4, and numbers that are bigger than 4, 5 and 6. So if I plug 3, 2, 3, 5, and 6 into my equation, I should go ahead and come up with what this table should look like. So let's see how this turns out. If I plug in 2, 2 minus 4 is negative 2. Negative 2 squared is 2. Negative 2 times negative 2, that's a lie. Let's try that again. 2 minus 4 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 3 is 5. 3 minus 4 is negative 1. Negative 1 squared is 1. Negative 2 times 1 is negative 2 plus 3 is 1. 5 minus 4 is 1. 1 squared is 1. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. 6 minus 4 is 2. 2 squared is 4. 4 times negative 2 is negative 8 plus 3 is negative 5. I need to double check. I'm making a mistake here. Maybe both of these should be negative 5s, not positive 5. Why? Because I'm doing negative 2 times 4 plus 3 for both of them, and that should be a negative 5. So I can go and I can plot the point 2, negative 5, and then 3, 1, and then 4, 3 is already there, 5, 1, and 6, negative 5. But remember, my line of symmetry shows that things are symmetrical. So I have this shape coming down like, oops, undo that last part. I have my line coming down like this, but do you see that these 2 points are, mirror images, and these 2 points are mirror images of each other? Here's my shape, here's my graph, but is there an easier way to find those 2 points? And we're going to talk about that in just a minute. I want to see what other examples I have real quick. Okay, I'm going to show on number 3 how to do that, and then we'll go from there. So real quick, as earlier, oh no, I don't need those. What I need to fill out down here is my domain and my range. My domain, x is an element of all real numbers. I can pick any x, plug it into this equation. It's going to give me a y. But my y's are all going to be less than or equal to my y coordinate. My y coordinate was 3, so less than or equal to 3. So that's my graph. That's what it's look like. That's what's my vertex. It's definitely more narrow than y equals x squared. So my domain is x is an element of all real numbers. My range is y is less than or equal to 3. Let's try another one. Number 2. Actually, I'm going to come back to number 2. I'm going to skip forward and do number 3, then we'll do 2, and then we can do 4 and 5. Now, why in the world am I doing this? Because I want to show you a technique that I think makes some of this a little bit easier. Y equals x minus 1 squared plus 2. What are the coordinates of the vertex? Again, I want h, comma, k. H is the opposite of what's inside, so that's 1. K is what's on the outside, so that's 2. So my vertex is 1, 2, which is that point right there. What is the effect of the value of h on the graph? It shifts the graph right 1. What is the effect of the value of k on the graph? It shifts the graph up 2. What is the value of a? There is nothing between the equals and the parenthesis, so a has the value of 1. Would the graph be wider or more narrower than y equals x squared? Actually, it's going to be neither. It's going to be the same size as y equals x squared. Why? Because a is 1. Would the graph open up or down? It's going to open up because a is positive. What is the equation of the axis of symmetry? It's going to be x equals the x coordinate, x equals 1. So here's my axis of symmetry. Now, algebraically, I can show you where this next step comes from, but right now, I want to show you a technique. On the last problem, I did an XY table to find my other points. I put my vertex right in the center, and I went ahead and I plugged in x and y, but it followed some sort of a pattern. And what's that pattern? That pattern turns out to be kind of interesting. I want to start at my vertex, and I'm going to go out 1 and up 1. Then I want to go out 1 and up 1, 2, 3. Then I want to go out 1 and up 1, 2, 3, 4, 5. And that's going to be the right side of my parabola. I can do the same thing going left. Go out 1 and up 1, out 1 and up 1, 2, 3, out 1 and up 1, 2, 3, 4, 5. This is going to give me the exact same graph as if I had plugged in x and y coordinates, plugged in x coordinates and got y coordinates out of it. It's going to work the same way. Let's just double check. If I picked x and y, and I picked x to be, well, 0, y turns out to be, well, 0 minus 1 is negative 1, squared is 1, plus 2 is 2. Look, 0, okay, that would be helpful if I said that 1 plus 2 is 3 instead of 1 plus 2 is 2. 0, 3 is that point. The other point over here is 2. If 2 minus 1 is 1, 1 squared is 1, 1 plus 2 is 3. 2, 3 is this point here. I'm getting the exact same points as if I did the table, but this 1, 1, 1, 3, 1, 5, 1, 7 will always work. I want to go out 1, up 1, out 1, up 3, out 1, up 5, out 1, up 7, and that's always going to give me my parabola shape. Now, the domain. My domain is x is equal to, x is an element of all real numbers. My range is y is greater than or equal to, since a is positive, my y coordinate. So y is greater than or equal to 2. That's my graph. That's my coordinates. That's my vertex, my domain, and range. I'm going to go back to number 2. If I go back to number 2 at the bottom of this page, I want to use that same method, but I have this pesky a in front. And like I said, the way it works is you go out 1, up 1, out 1, up 3, out 1, up 5. And I'm going to do that to my left and my right. And I get my parabola shape. This is going to work if, see, that's what my parabola shape would look like. This would work if a is equal to 1. What if a is equal, as in this problem, a is equal to 0.5 or 1/2? Well, I have to multiply a times each of the going up. So instead of, I would still go out 1, but instead of going up 1, I would just go up 1/2. Go out 1, instead of going up 3, go up 3/2. Go out 1, instead of going up 5, go up 5/2. I'm still going to get the same shape, but it's going to be wider than normal. I messed up on that one. I should have come higher over here and then done that. So the the shape still fits, the little pattern still works, it's just a little off. Again, worst comes to worst, you can do an XY table, put the vertex in the center, and plug X and Y's from the left and the right. Let's try to do this one. What are the coordinates of the vertex? Well, I want the opposite of what's inside, so that's plus 3, so it's a negative 3, and then exactly what's on the outside, so that's negative 6, negative 3, negative 6. So I'm going to go left 3 and down 1, 2, 3, 4, 5, 6. There is my vertex. What is the effect of the value of h on the graph? It shifts the graph left 3. What's the value? What is the effect of the value of k on the graph? It shifts the graph down 6. What is the value of a? A is 1/2. Will the graph be wider or more narrower than y equals x squared? It's going to be wider. Why? Because a is between 0 and 1. Would the graph open up or down? It's going to open up. Why? Because a is positive. What is the equation of the axis of symmetry? That is going to be x is equal to the x coordinate, which is negative 3. So over here is my axis of symmetry. Okay, here's my graph. I know it's going to open up. Again, I'm going to use this pattern. I'm going to go out 1 and up. Instead of up 1, I'm going to go up 1/2. Out 1 and up 3/2. Out 1 and up 1 to 5/2. It's going to be more wider. Out 1 and up 1, 2, 3, 4. Excuse me. 1, 2, 3, 4, 5, 6, 7 halves. 7 halves is 3.5. 5 halves is 2.5. 3 halves is 1.5. I'm going to do the same on the left. Go out 1, up 1/2. Out 1, up 3 halves. Out 1, up 5 halves. Out 1, up 7 halves. And again, it's a mirror of on both sides. If I draw my parabola, this is the shape that I get. Again, the order is out 1, up 1. Out 1, up 3. Out 1, up 5. But since a is 1/2, all the ups have to be cut in half. All the ups have to be cut in half. I have to multiply by that a. There's my graph. That's what it looks like using this quick technique to graph it. Okay, what's my domain? Domain, as always, is x is an element of all real numbers. What's the range? My range is y. It's facing up is greater than or equal to my y coordinate, which is negative 6. So, how much time do I have? Plenty of time. Not really, but that's okay. You can endure. Let's do 4 and 5. Numbers 4 and 5 are going the opposite direction. Write a quadratic function in vertex form for the parabola shown below. All right, now I'm given the vertex. My vertex is the coordinate 2, negative 3. The given point is the point 4, 1. The quadratic function. I know in vertex form it's y is equal to a times x minus h quantity squared plus k. So immediately I can say y is equal to a times x minus h squared plus k. But I know what h and k are. My h is 2 squared. My k is negative 3, so plus a minus 3. So it's y equals a times x minus 2 squared minus 3. But I don't want a. I want a number in there. That's where this 0.41 comes in. If I write that equation, y is equal to a times x minus 2 squared minus 3, I want to plug in this coordinate of 4, 1. This is my x. This is my y. 1 is equal to a times x, which is 4 minus 2 squared minus 3. 1 is equal to a times 4 minus 2 is 2. 2 squared is 4 minus 3. Add 3 to both sides. 4 is equal to 4a. Divide by 4. A is equal to 1. A is 1, so that's my equation. Y equals 1, x minus 2 squared minus 3. Y equals x minus 2 squared minus 3 is also the same thing. My domain, x is an element of all real numbers. Range, y, its facing up is greater than or equal to the y coordinate, which is 1. Oh, negative 3. I was looking at the wrong problem, or wrong point. Y is greater than or equal to negative 3. So I plug in my vertex into the equation, and then I need to find A by using the second point. Let's try it one last time. My vertex HK is negative 2, 1. My equation is y equals A times x minus h quantity squared plus k. Given point is the point 1, negative 1. My a should be negative. It should turn out that a is negative in this problem. Let's try this. So the quadratic function is going to be y equals a, whatever that is, times x minus h, so x minus 1, plus squared plus k. K is a negative 1, so it's minus 1. So I'm going to plug in what I know. I know from my given point that y is negative 1, x is positive 1. So negative 1 is equal to 0 squared minus 1. Negative 1 is equal to, there should be an a sitting right in front there. Should a minus 1, add 1 to both sides. Hold the phone. So there was a little mistake there. Let me fix it. It's right here. My vertex is negative 2, 1, not 1, negative 1. So it's x minus h. H is a negative 2, so that's x plus 2 squared plus k, where k is 1. Using the wrong point. I need to make sure to use the vertex. Now I need to find my a once again. Now, using this point, y is negative 1, a is what I'm looking for, x is 1, h is negative 2, so that's plus 2 squared plus 1. So negative 1 is equal to a times 3 squared plus 1. Negative 1 is equal to 9a plus 1. Subtract 1 from both sides. I get negative 2 is equal to 9a. It's a 9a. Ignore that bell. Divide by 9. And I get a is equal to negative 2/9. So then my equation is y equals negative 2/9, x plus 2 squared plus 1. My domain is x is an element of all real numbers. My range is y is equal to, it was a negative. It turned out to be negative just the way I needed it to. Y is equal to, is less than or equal to my y coordinate, 1. There's my points. There's my equation. Have a good day.